Welcome to the LOGSTAT, the Army's premier podcast on all things sustainment, where we analyze new developments, discuss current trends, and forge the path ahead for the next generation of sustainment soldiers. Hello everyone, welcome to another episode of the LOGSTAT. I'm your host, Captain Garett Pyle. Advancements in technology have always been at the heart of manufacturing for the Army. Thus, on today's episode, we're going to explore the next step in manufacturing, which is referred to as the Advanced Manufacturing Strategy. Leading the charge in this initiative is the Ordnance Corps, and to guide us along as we analyze the impacts that this strategy will have on the force, I have with me today the Chief of Ordnance, Colonel Rob Montgomery, and the Ordnance Chief Warrant Officer, Chief Warrant Officer 5 Kent Shepherd III. Current Rob Montgomery graduated from the University of Washington in Seattle, Washington, and was commissioned through its Army ROTC program in 1997. He holds a Master's in Public Administration from the University of Kansas and served as a National Security Fellow at Harvard's John F. Kennedy School of Government, Belfer Center of Science and International Affairs in Cambridge, Massachusetts. He has held numerous tactical and operational assignments to include service in Korea, Fort Bragg, Fort Hood, JBLM, and Fort Benning, with strategic and joint assignments at the Pentagon, in Italy, and MacDill Air Force Base. He's had multiple combat deployments to Iraq and Afghanistan, participated in numerous operations and exercises, bilateral and multilateral engagements throughout the world, and he planned, supported, and participated in several humanitarian aid and disaster relief missions both in the U.S. and abroad. Chief Warrant Officer 5 Kent Shepherd III is a native of Belmont, New Hampshire, and enlisted in the Army in 1996 as a 63 Tango Bradley fighting vehicle mechanic and crossover in 2003 to become a 915 Alpha Automotive Maintenance Warrant Officer. Chief Shepherd's most recent assignment was as a G4 Senior Ordnance Warrant Officer in the U.S. Army Southern European Task Force, Africa, in Italy. His previous assignments include Fort Campbell, Fort Rucker, Schofield Barracks, Fort Bragg, Fort Drum, and Germany, with multiple deployments to Kosovo and Iraq. He earned a Bachelor's of Science degree in Liberal Arts and Management from Excelsior University and a Master's of Arts in Theology and Church History from the Rawlings School of Divinity at Liberty University. For a complete bio on Colonel Montgomery and Chief Shepherd, be sure to check out the Ordnance Corps' website under their command group in the About tab. I'm so excited to have you both on the show today. Welcome.
Hey, Garrett, thanks for having us. We're excited to talk about one of the main pillars that we do in the Ordnance School in reference to advanced manufacturing.
Yeah, I'm excited to be here, and I think Colonel Montgomery has said multiple times that this is the year of the 914 Alpha Warrant Officer. This is the year of our 91 Echo Allied Trades NCOs because we're making some big changes across the Army.
And I'm just really excited to get into this. And as we were talking, Chief, I know before this, this is nothing new. This is something that's been going on all throughout the history of the Army when it comes to manufacturing. And so I kind of want to start this off is get a solid understanding for the audience is what is advanced manufacturing?
Sure. So when we think about advanced manufacturing, it's not your traditional manufacturing warehouses of the past, and we'll talk a little bit more about that. But it is important to understand the definition when we talk about advanced manufacturing, what it refers to. So it essentially refers to the use of innovative technologies, processes, and materials to improve products that we are designing, producing, and sustaining, right? So it goes, again, beyond the traditional manufacturing because we are integrating, in a sense, modern science. We're integrating data and automation. And so when we look at the ecosystem of advanced manufacturing, there are several features that interact within each other that are, in some cases, symbiotic, right? So we have digital integration, right? And so advanced manufacturing includes that, which is the use of computer-aided designs, CADs, or computer-aided manufacturing, CAMs, the use of digital twins to simulate a process or an object or a device, whatever you're trying to produce before the physical production is actually implemented. That's one piece of the ecosystem. The other piece is the automation and robotics, and we see that in the defense industry all the time. When we're incorporating actually robots and automated systems to build the item that we're looking for, right? The use of machine learning and artificial intelligence, right, which creates speed, precision, and minimal errors that we humans would likely be, applying if we were trying to build an item by hand. The third thing is additive manufacturing, and that really is really what we do here in the school too, right? 3D printing, and everybody has a 3D printer, it seems, but the 3D printing and technology, just like the simple printer in your home, allows for layer by layer production. Very complex parts. We don't have the huge waste afterwards when we do normal manufacturing compared to additive manufacturing. And then we have smart manufacturing, right? That's the use of sensors, data analytics, and just, a myriad of things in the industrial internet base, if you will, where data can predict logistics failure, right? So when we look at predictive logistics, if we're plugging in, we understand the data of a machine, we could predict whether those parts fail, thus, taking the advanced manufacturing, additive manufacturing to build that part in the future. And then advanced materials, right? We can't do advanced manufacturing without advanced materials, right? And so technology today shows us that we have, different types of polymers of different strength, flexibility, and different types of composites, the use of nanotechnology, and so forth. So all that coupled together in the ecosystem, I call it, of advanced manufacturing, is really a symbiosis of products and techniques and skills and technology all coupled together to produce the right product for the system that we're trying to enhance, if you will.
A little bit of my background, my father was a machinist, and so I grew up in a household where I saw machinist tools. I probably had seen a caliper and a micrometer before I could even walk. And as you think of the evolution of manufacturing, we went from having blacksmiths who were hammering different tools and things that they were making nails, making hinges, to then using a foundry and casting different parts. And then we had machinists who were going through and they were working on those parts using a file. And then as you follow that thread, we began to then get lathes and mills where we had electronic machines that were going through and removing big chunks of metal so we could make engines and other parts. Advanced manufacturing is really revolutionary, and it's really kind of unique because when you look at the whole idea of 3D printing, the technical term is stereolithography, and it was invented in 1983 by an engineer named Chuck Hull. And so, although it's a few decades old, I would say it's really kind of leaped bounds over the past 10, 15 years or so. And so, when you look at how do we make a part, we have to design a 3D model of it, and we use computer aids to design that 3D model. And rather than going through in years past where we subtracted, we removed material, we're not doing that anymore. What we're doing is actually building up material. And as Colonel Montgomery said, that limits the waste, it reduces overall costs. However, there's a huge upfront cost because these machines are super expensive. But nonetheless, that's kind of the umbrella of what this is. You take the 3D model, you can print these parts, whether you're doing it using plastics, you can do it using metals, and there's all sorts of other ways. I'll talk a little bit more in future, in this conversation about the different types of how we're adding metals to these parts that we're manufacturing.
So this is just a good way to really get our conversation going. And sir, you brought up some points we're talking about predictive logistics, the data-driven, the artificial intelligence. We've had multiple different conversations on previous episodes, so it's nice to see and unique to see how all these different elements from things we've talked about previously is really all coming together and now creating this advanced manufacturing strategy. We're using all these concepts that we're using for other things when it comes to sustainment, but how it's really driving this next step in advanced manufacturing. And as we kind of go forward, can you tell us more about this technology that's really driving this, kind of get more into, so we can have a better understanding of that for the audience?
Sure, absolutely. So within our military domain, and we look at war and the speed of war, and we look at in terms of the length of war and distance, and when we go to war, we go to other countries and we fight, and we bring our equipment, and our equipment breaks, and so we have to rely heavily on the supply system, right, and really at scale, and so I recall my time as a young company commander in a tank formation, and parts for tanks, that we don't traditionally replace are blown up, and it's not in the supply system. And there's this particular part of this Abrams tank, for example, and when I was in Iraq in 2004, that was damaged, right? And it literally took 6 months to get that part because that part was not in the supply system, right? And so that's just a small example. And so how do we sustain the momentum of combat operations with our equipment and our kit, and at far reaches on the forward lines of troops at the point of intended use, and without having to rely so much on the supply chain to get a particular part, it doesn't matter how small or how big, right, to the front lines. The Army in the past decade has worked hard on challenges with the supply chain and trying to get things to the point of need. Advanced manufacturing has closed that gap significantly. So when we talk about this technology and why advanced manufacturing and why we have changed our curriculum, and as Chief said, the 91 ECHO Allied Trade Specialist MOS, Military Occupational Specialty MOS, they're far more valuable than they were in yesteryears. They're not cutting and welding anymore. They're doing far more than that. They're 3D printing. They have to understand everything that I talked about in terms of the ecosystem of advanced manufacturing. They have to understand those things. And later on in this conversation, we could talk more about how we are training those soldiers to be advanced manufacturing experts.
Yeah. So as I look back upon my warrant officer career, I think back when I was a young W01, CW2, if I had a vehicle that was down on the legacy 026 print, we now call it the equipment status report, the ESR. But back in the day, if a vehicle was down for more than 60 or 90 days, I remember that we'd be getting nuked. Like, why is that vehicle down? And as I contemplate the difference between when I was coming up 20 plus years ago as a young warrant officer, the nature of how we sustain, how we get repair parts has changed in our organic industrial base. And so we've modernized our equipment across the Army at an incredible fast pace, as well as we're still sustaining legacy vehicles that are, quite frankly, past their life cycle. And so we're really trying to solve two problems. The first problem is obsolescence with an old vehicle that we're trying to maintain. And the second one is parts provisioning for a new piece of equipment that we just received. And when you're sitting in a maintenance meeting, whether it be at the brigade level or you're at the division level, and you have your DLA representative there, and you're looking at a long lead time part, and you have a ship date that's out 1 year, sometimes even 2 years out, and then you start to ask the questions, why can't we get that part? Well, there's a contracting requirement at DLA, and they have to go through a bidding process. There's legalities before they award the contract, and we have to incentivize it for that manufacturer to actually make the part. And sometimes the quantities that we need are just so low that the juice isn't worth the squeeze for these manufacturers. And so we've got all these challenges with getting these parts. Now, when you look at advanced manufacturing, this is revolutionary. And I'm going to say because of two specific reasons. One of them is what is happening right now under TACOM at the Joint Manufacturing Technology Center at Rock Island Arsenal. So what they are doing right now is they are taking a lot of these long lead time parts. They're having their engineers either reverse engineer them, come up with the actual mechanical design, the 3D design of that item, or they're getting the tech data packages that came from the original equipment manufacturer, and they're starting to produce parts for the Army, which is just great. And TACOM is actually underwriting a lot of the risk involved with those parts. The second thing that we're doing is my 914 Alpha Allied Trades Warrant Officers, as well as my 91 Echo Allied Trades Specialists, they're doing reverse engineering themselves. They're using the SolidWorks program. They're taking all the measurements with their micrometers, entering those measurements into SolidWorks. They're creating what's called an STL file, and that's just basically a 3D design. That STL file then goes into a slicer design, which then gives you all of that specific layering so that we can build that part up and print it. And what's really neat is we can print a part using polymer, using plastic, make sure that it matches the fit, form, function, design before we actually move to subtractive manufacturing. So once we know that it fits, that part's good, then we can go to the mill, the lathe, we can take subtract the metal and then machine that part and put it onto the vehicle. So that's kind of the way that we're going right now. I think it's a great time for advanced manufacturing across the military because it's gonna reduce the time that we're waiting to get those vehicles off the print.
Well, definitely, thank you, Chief, because it's unique, especially how you're talking about, and we're getting to a little bit later on when it comes to the schoolhouses, what everything's doing, just how your different MOSs are really leading the charge with these initiatives. We talked, and it seems like, and you correct me if I'm wrong, a lot of this is like at home station. Is this the technology comes to 3D printing and some of these manufacturing? Are we able to deploy this forward, or is this technology would be just at home station?
Yeah, so what's really great is you look at what we're doing in terms of giving these soldiers the tools that they need to manufacture the parts. We have what's called the Metalworking Machining Shop Set, the MWMSS. And every single brigade support battalion, the standard brigade, has what's called the Type 1 and the Type 2, which comes with a mill and a lathe as well as a 3D printer. So we're giving them the tools that they need right now to do these designs and to make these parts. The MWMSS is deployable. So these two shelters sit side by side. We can haul them where they need to go on the back of a PLS, drop them on the ground. They can set them up, and in a matter of hours, they can start to manufacture parts.
Well, definitely thank you for that. So it's good to see that this isn't something that exists only in home station, because we mentioned before, a lot of our operations are overseas. So be able to take this capability and actually deploy forward so we can get that part, reduce lead times, as you said, sir. So to get that item, that part, back out to the maintainer so they can get that equipment back up and running and back out to the fight. So it's really good to see, because even though we've talked about at the beginning, this technology or the way we've been doing manufacturing has been since the beginning, as we said, back to Valley Forge, but it's that technology. We can increase the rate and the efficiency now on getting these parts made. With the technology, it helps reduce waste on that. But we're talked a lot about all this unique kind of stuff we're able to deploy forward, but are there going to be risks associated with this manufacturing strategy?
Sure. So, there's always risk, right? We all know with new technology, right? And so, and this is a common question during all our conferences, engagements when we talk about advanced manufacturing. So let me just kind of lay out, and again, in a broad stroke, the risks associated with advanced manufacturing with us in the military and how we employ AM. So the first risk that we have is the cybersecurity and data integrity, right? And so AM, advanced manufacturing, depends on digital design files, CAD modules, digital twins. And when we look at all that intellectual property, that is sensitive property that could be stolen by adversaries, corrupted, manipulated, and so forth. So that's the first risk. So the cybersecurity when we transfer files on these printers, and when we look at file transfer to the forward line of troops from the rear line, right? If a soldier requests a part but needs the CAD file for that part to be transferred, that's one of the major risks we have. The other risk we have is quality control and certification. And so, and I'll pass the chief in a second to talk a little bit about that. But these mission critical parts, these parts that don't break routinely on these big combat systems, and that we're able to machine and make and 3D print, reverse engineer, we don't have the capability and the frontline trace units to pressure test certain types of metal, right? And so when we print a part, for example, at Abrams 3D print Abrams tank fuel line, right? The metallurgical strength of that fuel line may not withhold, the pressure, the climate, and so forth, right? That where that tank is, it might be less than that OEM part. But we have, fortunately, I would argue that most of the parts that we print are better than the OEM part. Supply chain over reliance, and so we're not really reliant on the supply chain if we could produce the part forward. However, we can't produce the part at scale or mass because we only have so many machines, right? And then there are certain parts, material that we need, right? Resin, powder, certain types of metallurgical powder we need to put together. So we don't have that equipment to make those strong or raw materials to make those strong parts. I talked about the intellectual property, but the other part of the intellectual property is the authorities to make proprietary parts from our combat systems, right? Let's say, for example, hypothetically, if we printed a whole entire engine of a Stryker, well, that null and voids that contract for that Stryker, the OEM, and Chief could expound on that a bit. The training and workforce gaps that we have. This is why we've pressed hard on the 914 and the 901 Echo. People have printers at home, and they could print anything. Right. And so in some cases, some are very good and some aren't. We have to standardize our training to make sure that the specifications of the part is within compliance. And so making sure that the soldiers are trained appropriately. And then the last thing I would say is, the overpromise versus reality. Yes, we could print parts at the point of need, but we still need the industrial base, like the joint manufacturing facility, Rock Island, to print major parts, right? Because they have all the equipment there to ensure the parts printed on time with the right specifications and so forth. Remember, when we print parts forward, we're printing it. We're assuming we're printing the part or that particular piece in a very austere environment, where there is no controls, there's no air conditioning, there's probably not enough power because these machines take a lot of power to run. Chief?
Yeah, so as I think about risk, sir, I think one of the biggest challenges we have right now is that advanced manufacturing is the latest buzzword. And we have a lot of commanders that are hearing that this capability exists, and they're a little bit leery about putting one of these parts on their vehicles. And as I kind of roll back the clock and look at my younger days as a warrant officer, I remember every time something was I had a deadline fault in a 5988 that came across my desk. Before I would sign off on that 5988 saying, yes, this vehicle needs to be deadline, I would do a triage. And I would ask a series of questions. Number one, is it the right national stock number? Number two, is it the right usable on code? Is that the correct NSN for the vehicle that we're ordering the part for? Number three, is it available anywhere on post that we can do a walk-up at an SSA, or does one of my sister units have that part on hand? And then additionally, I'd ask, is there a next hire assembly? And the last thing that I would always ask my maintainers is, can this part be fabricated? So we have had allied trade specialists in the Army for decades who have been trained with the capability to make these parts. And we look at this problem now with advanced manufacturing as if this is something new, but the reality is the Army has invested a lot of capital and a lot of time in training these warrant officers and NCOs how to make these parts, but also understanding the risk involved with doing so. And so my 914 Alpha warrant officers are equipped to advise that commander, in terms of the metallurgy, will this part do what it is designed to do? And if it does break, how much risk is involved with it? And we've all done, a composite risk matrix, risk assessment matrix, where you look at the severity and the frequency, and then you have, that what's the overall risk, and then you implement controls. And those controls give you the residual risk. So when we look at putting a part on a vehicle, we have to ask those questions. If this part is for a steering component, certainly has a whole lot more risk than a part that goes to a windshield wiper. And so we have to be able to intelligently look at that and ask those questions, but then also talk to our 914 Alphas, look at what they've done to design that part. And I would say oftentimes what my warrant officers are able to do is to manufacture a part that exceeds the OEM specifications. And I would say the same thing is happening right now at the Joint Manufacturing Technology Center. So what they're doing out there is they're taking the tech data packages, they're reverse engineering these parts, and they're making it a lot better than the OEMs, because the OEMs are doing so to make a profit. And they're mass producing these parts, and over time these parts are breaking because they're made with failures. But when JMTC makes one of these parts, it actually exceeds the OEM specifications, and they've been putting parts on vehicles for several years now that have not broken, that have performed way better than the OEM. What they are doing at JMTC is they're uniquely powder coating and painting their parts a special color blue, so they look different than the OEM parts. And so you can always look at a vehicle, you see that blue part, and it has its own little special serial number that says BDRF, Battlefield Damage Repair Fabrication Part, and you'll know that that was made at JMTC. So that's just the whole idea of the risk. This isn't anything new, but commanders really need to trust their 914 Alphas and then do that assessment to determine the residual risk and whether or not it's the right decision to put that on the vehicle.
And I think it's really good to be. We always said that, as you said, sir, we have to be able to identify the risks and put the controls in place. That's just part of, as commanders, to be able to assume that risk. And as you brought up, Chief, is, trust those who have been going through this. Trust those who have received the training, and this is like their primary thing that they have learned, and it's become a craft to them. And it is a great segue into our next part. Is really, how is this affecting training here at the Ordnance Schoolhouse on this advanced manufacturing? How is it adapted or changed the schoolhouse here?
Sure. So, Kent Shepherd is heavily involved in changing POI, right? And so when we look at our allied trade specialists and warrant officers, we have coined the term we want them to do is think digitally, right? Print tactically, repair strategically. And so that's sort of the mantra, if you will, for the Allied Trades Department, right? And I've charged Mr. Shepherd with a detailed, comprehensive look into how do we shape our instruction and curriculum to fit the advanced manufacturing demand of our soldier of the force. And then so our soldiers, when they go out, they're skilled.
Yes, sir. And so I would say that whenever we have VIPs, general officers, and congressional delegates, anybody that comes to Fort Lee and they want to come visit the Ordnance Schoolhouse, the one place that everybody wants to see is our advanced manufacturing training. And so they all want to get down there and see the 3D printers and to see the 91 Echoes churning out all sorts of really cool parts. And our current model right now for our 91 Echo AIT, we're only teaching them 18 hours of 3D printing. But moving forward into FY27, we've basically tripled our training. And so we're bumping it up to 64 hours. So we're expanding this curriculum to now cover CAD design, SolidWorks, using the Prusa slicer to do the slicing, using the CNC G-code basics, and then hands-on 3D printing. So we've tripled it for AIT. Additionally, our ALC, Advanced Leaders course for our non-commissioned officers, our current model, we do not have any training at all when it comes to 3D printing, advanced manufacturing. Moving forward in FY26, we're going to give them 26 more hours of CAD CAM 3D printing and then an additional 160 hours of CNC machining. And so we look at the CNC machining as complementary to the 3D printing, because if you understand code, whether you're subtracting or adding, it all kind of talks the same language. Now, when it comes to my warrant officers, we're also increasing that as well. We're bumping up the hours for my warrant officer basic course to over 260 hours of education, 80 hours on additive manufacturing, another 180 hours of CNC subtractive manufacturing. We have a brand new course that's coming out in FY 2026 called the Warrant Officer Intermediate course. And this course is going to introduce over 216 hours of advanced manufacturing. And then we're also redesigning our Warrant Officer Advanced course, and that's going to be for our CW3s. We're giving them over 300 hours of hands-on training. So I think that we've really invested a lot of time and energy in ensuring that we give the right education to our NCOs and to our warrant officers, and we're going to really help generate readiness across the Army.
It's just great to be able to see what you all are doing at the schoolhouse, how you're diving in and say, hey, we need to increase these hours. We need to ensure that the soldiers that are being trained have the adequate time, hands-on experience before they get out into the force. They can take everything they're learning at the schoolhouse and then also be able to help instruct and teach those of the units they get to. Especially because, as you said, like some of these, and these upcoming FYs is when we're putting this training into place. So there's going to be some people, as we're in this period right now, who haven't received all that training, but they're going to be able to learn from those who just have. So it's good to see the impact that you all are making with that. And because we are kind of in this in-between period right now, and I'll kind of term it or coin it as like this inter-technology period, so to speak. You spoke about it earlier where we have some legacy systems still. We still have the Humvee in circulation. It's been around for a hot minute now, but then we have newer vehicles. We have the Joyride Tactical Vehicle, the JLTV is being used. We have the Infantry Support Vehicle, which is coming out, the ISV. So we have all these new equipment that our mechanics are going to be, tasked with working on, as well as legacy equipment. So we're in this inter-technology period, so to speak, between old versus new equipment. So how do we operate in this environment now, especially when it comes to parts and everything with this period?
Sure. So that's Garrett. That's a great question, right? And I remember in Command and General Staff College understanding and learning more about our history, right? And so when we talk about the interwar period, right, it's important to understand the interwar period. And I like the term inter-technology period, but the interwar period, as we remembered, was a time of fragile peace, right? There was an attempt to prevent another world war, right? So it was really in between World War I and World War II. The international institutions were failing, economic collapse, ideologies were rising up. And so if you look at, the time period between wars, you kind of see the same systemic trends. And then from the military piece, what happens in between war? We start focusing on revamping those lessons, especially this last 20 plus years of war, and improving, increasing, seeking out new innovation, changing our doctrine, developing our staffs, and then more importantly that we've been focused on here in CASCOM and the Ordnance School is developing new signature modernization efforts, right? So to your point, in terms of technology, the inter-technology period, which is actually, in some cases I would coin the gray zone of innovation. And so, as you mentioned, that's a span of time now, same thing between wars, where one major technology it continues on, and then we start to adopt a new technology as its successor, right? And so the in-between piece here, where old technology and new technology still coexist, but they still overlap, they're still competing, and we're still trying to outfit organizations. So what's all that mean? It essentially is this. Okay, we have the Humvee, and the Humvee's been in existence for the last 30 plus years, I would say. Now we have a new wheel vehicle, right? And but if you recall, and you mentioned this, during 20 years of war, we've developed other wheel vehicles, armored protected vehicles, Max Pros, MATVs, and now the JLTV. And now we have seen in the force the infantry squad vehicle, the ISV, right? And it's not necessarily a Humvee replacement, but eventually it will be, right? But it has different technology. What's that mean for us? Well, it means a lot of things, right? But more importantly, we have to train our young soldiers to work on a new system. Simultaneously, they still have to understand the old system, because in the force right now, we have old and new. And, we have our track vehicles, upgrades to the M1 Abrams, upgrades to the M2 Bradley, the new XM30, the Bradley replacement coming out, right? So that's going to have second, third order effects on our curriculum and changing how we do business, right? And so we have a population of 91 series maintainers and repairers out in the force right now. We have to bring those individuals back to retrain them on new equipment and new technology. Those 91 Echoes and 914s, allied trade specialists that are in the force, they are learning about advanced manufacturing, but they're only learning a small piece of it until they come back to the school where they're going to get the full curriculum in all the facets associated in the ecosystem of advanced manufacturing. So that technology piece is forever changing. The worst thing about advanced manufacturing with a 3D printer is they're building a new printer every month, every week, every year, right? And they're very costly now. And just like the Apple IIc computer back in the 80s, costing an arm and a leg, to now we have different types of computers that do the same thing at a much cheaper cost. So we have to also look at cost too when we get when we focus on these new technologies.
So the way I look at that question is we have a repository right now that I want to briefly talk about called the Advanced Manufacturing Data Repository. And so this is kind of owned by Army Materiel Command and TACOM. And what this repository does is it hosts all of those tech data package files that my machinists need to manufacture parts. But we have a limited amount of files that are currently in this because we're still kind of growing this capability. And as we think about manufacturing parts at the point of need, if we're talking about large-scale combat operations, my warrant officers are going to be pressed for time to go ahead and manufacture a part, and they don't necessarily have the time to reverse engineer every single part that they need to make. Every measurement that you take with a micrometer and then put that into SolidWorks and create that 3D design takes time. It takes hours. And so we're moving very fast, very hard across the enterprise to improve the Advanced Manufacturing Data Repository. And in this interim period that we're in right now, what we have is we have engineers that work for TACOM who are reverse engineering parts that are difficult to obtain, getting those files, uploading them into the repository, while at the same time, when it comes to our procurement of new equipment, we're also trying to ensure that we're purchasing those tech data packages to reduce that time frame so that we can put those files into the Advanced Manufacturing Data Repository and then reduce the overall time that it takes to pull those files down and print the part. And last week, we had a pretty cool thing happen. So within our schoolhouse, we were one of the first ones in the entire Army to be able to connect our metalworking machining shop set up and to talk with the Advanced Manufacturing Data Repository through the network. So previously, when it comes to the computer that we had that has the SolidWorks software on it, as well as a Prusa slicer, neither of those programs were authorized to be on the network, but we received the authorized to operate in the network. We're able to connect, pull down a file from the cloud, from the Advanced Manufacturing Data Repository, and manufacture it. So I see that being the way of the future, but we're going to be in this interim stage for a while longer as we try to get those files into that database. But the future's bright, though, sir.
So, and I think that's right. As we go through and continue to develop this technology, we will be in this intertechnology period, especially because some units they might have the Humvee for a lot more time, because it is an older piece of technology. It doesn't have all electrical systems as these new vehicles have. So people are going to the schoolhouse now. They're learning to be able to, they have to work on Humvees, they have to work on GLTVs, so they'll have to be very diverse in their skill craft to be able to react to whatever type of unit they go to, because you go to any type of unit, especially as a mechanic. And now on that, we're talking a lot about what you all are doing at the schoolhouse here. Then how does that work with, like, are you partnering with civilians, like civilian counterparts, civilian schooling, or like maybe some of our companies out there on how they're utilizing technology?
Yeah, so the Ordnance School, has partnered and is partnering with several outside organizations. I'll talk about it in a second, but it is important to understand that as we look at technology, today, that technology is everywhere, and so part of our job is to go seek it out. We don't have a cell full of industrial engineers or computer scientists, or any type of engineers. So we have to find those individuals and seek out outside of even the industrial base, right? So what we've developed relationships with, this last year was University of Maine, the Advanced Structures and Composite Center. And what they have shown us is they have the largest 3D polymer printer in the U.S. in the world, and they've already printed 2 boats, LSVs, for the Marines, right? They've already, and they're testing them right now, and so they're able to put a JLTV on that LSV or in several containers. And so they also do a myriad of things in their department with engineers, and they're also partnering with DoD for other technology. So we in the school, we're seeking out some of their programs and developing a relationship so we could improve our curriculum here. The second institution we are partnering with is the Institute of Advanced Learning and Research out in Danville, Virginia. And their advanced manufacturing division really spearheads and accelerates the training in the industrial base by bringing in the civilian population and really helping their economy too. And the students that they bring in, they're training them on all aspects of advanced manufacturing, so they could go back into the defense industrial base and be those welders and printers and fabricators for our industrial base institution. And the third place is Austin Community College. Actually, Austin Community College has a relationship and partnership with Tesla. And so what Tesla does is they provide Austin Community College with funding and equipment in terms of robotics and advanced manufacturing. And so what Austin does is they bring in students, STEM students, and teach them all things on AM and robotics, so they could go back into the Tesla workforce or perhaps SpaceX and start working for the company. So those 3 companies, I personally visited. I've taken some lessons. We're developing some cross-pollination and using some of their curriculums and their equipment, their instruction to enhance our allied trade specialists in the school.
Yeah, so one of the other things that we did is, and I'm going to kind of boast about my boss here. So he coined a phrase last year. I was in the meeting, and so we're all familiar with training with industry, where we take an officer and we embed them with, GM Defense or AM General or some other civilian organization, manufacturer for a year, so they gain experience. But he coined the phrase training with enterprise. And so he recognized that we have a lot of capability within our depots that we would like to tap into to get that education and training to bring it back out into the operating force. So we brokered an agreement, a relationship with Rock Island Arsenal at the Joint Manufacturing Technology Center to do a shorter iteration of training with enterprise. And I was able to send 4 of my warrant officers out to JMTC this past July to go through 2 weeks of hands-on training with all of those engineers. And it was quite remarkable. They were doing all sorts of manufacturing that we don't even have that capability to kind of open up their aperture, open up their mind, one, to the capabilities that exist there, two, to improve their ability to manufacture parts. So they learned about build setup procedures. They did hands-on work with fuse deposition modeling, multi-jet fusion, low plasticity burnishing, directed energy deposition, cold spray, additive friction, stir deposition, and then post-processing. Now, that was a mouthful, and I'm sure that if you're curious about that, you can Google them. But those are all sorts of capabilities that we don't necessarily have at the operating force. But if you understand how it works, if you understand how the design works and how to do it, you can take that and you can apply those lessons learned. So we did that for 2 weeks. It was a really, really great opportunity for those warrant officers. But we're also opening up a year-long training with Enterprise for my 914 Alpha warrant officer to kick off next year. So we're going to embed a warrant officer at Joint Manufacturing Technology Center every single year to get all of that education and training, not only on advanced manufacturing, but also welding and all the different things that they do there, to take that back here so we can utilize them either within CASCOM, doing the capabilities development, or as an instructor, or as one of our training developers. And so I think that all that experience that they have there at GMTC, poured into our warrant officers, bring it back here, and then we can impact the broader Army.
Oh man, I like that, training with Enterprise. So I really like that term, and just it really shows the return on investment that you all are really investing into truly the next generation of soldiers, no matter the rank, and just be able to really take everything that we've talked about today when it comes to advanced manufacturing strategy and really get it set up very successfully for the next generation so that they're even more equipped than what we are now. So I think that's a great thing that you all are doing. And I know we can really talk about this stuff for hours on end, and there is so much more when it comes to advanced manufacturing that we've just haven't had a chance to hit yet. But as we kind of start to close out today, I always like to leave our audience with some wisdom. So I'll give to both of you a chance to, what advice do you have for the sustainment community? And I'll go to you first, sir.
Yeah. So, I mean, geez, there's so much advice I have for the sustainment community, but here's, let me flip this, to those listeners out there. Send me your cards and letters about advanced manufacturing. Send us your cards and letters and tell us what you're doing, and invite us out and showcase your technology, because, quite frankly, we don't want to find a one answer solution to encompass everybody in the force, because it's probably not the best methodology, right? There's different types of units now, just like the interwar period. We're changing doctrine. Not all units are created equal. Not all units will get the MWMSS. Not all units will have a 914. Not all units will have 91 echoes, right? And so what we're trying to develop here is a solution for advanced manufacturing that we could share across the board that will meet a majority of the requirements that the user needs. And so instead of me giving, you all advice, I want you to give me advice on, and counsel, quite frankly, on all the new things out there that I've missed, that I haven't seen. Because here in the Ordnance School, we're ever evolving. So I'd like to hear from you. And Garrett, I appreciate the time you have, and giving us this moment to talk about what we do in the Ordnance School. Very appreciative, and I look forward to our next discussion.
Yeah. So as my time as a CW5, I have done, I think, at least 40 maintenance terrain walks, serving as a CW5, both in the G4 of Southern European Task Force, as well as my time as a senior warrant officer in the 101st. And every time I come in for the introductory brief for the maintenance terrain walk, we look at the personnel management, and we look at the laydown of the ordnance soldiers. And I always see a slide where they are complaining about shortfalls with their ordnance MOSs. And then I turned to the command teams and I asked them a question. How many of those maintainers are not working in the motor pool, but they're actually in the orderly room? Or they're doing something else outside their MOS, and then they kind of get red in the face because they're like, ooh, I've got a couple of maintainers doing these other jobs outside of their actual task. And the reason I bring that up is because the skills that we give them, the training that we provide them from within Ordnance is a perishable skill. Every one of these soldiers who raises their right hand and enlists in the Army to become a maintainer does so because that's what they want to do. And so we have to kind of protect that as leaders as best as possible. I understand we all have to pay the taxes, but nonetheless to protect that. And when it comes to our allied trades personnel, both my 914s, my 91 Echoes, we have to leverage that capability. Otherwise, they're going to lose those skills. So I would ask you to employ the MWMSS, take it to the field with you, set it up during your FTXs, ask them to make parts, have your 914 Alpha with you at all of your maintenance meetings, and look at the ESR and ask the question, can we make this part? Is it smart to make it? Is it wise? Is it safe? And if it is, then do so, because that's the only way that we're going to get better. So I think that we all collectively have to steward this. We've given you a valuable resource, but it's up to you to employ it appropriately.
Thank you both very much. Greatly appreciate it, especially the wisdom, just everything we've talked about today. Like I said, there's a lot more we can get into. But so where can people find you at if they have any additional follow-up questions, or as you said, sir, your cards and your letters?
Yes. So goordnance.army.mil. Goordnance.army.mil. That's where you can find us. There's a button on there that says Ask the Chief. So that goes straight to me. And there's a button on there, I think, it says Ask the Sergeant Major, and I think one for you, right, Kent?
Yes, sir.
Ask the regimental warrant. So you could ask us anything, and then from there we'll receive your notes, and we'll reply back to you directly. We look forward to hearing from you. Go Ordnance.
Go Ordnance.
So I want to thank you both for taking the time to come in today and provide our listeners with an analysis of this advanced manufacturing strategy and the impact that it is and will have on the force in the coming years. I know your team is working on so much more, and we have more episodes from Ordnance on the way, so stay tuned for those episodes as they drop later this fall. I want to thank you both for taking the time to come in today and provide our listeners with an analysis of this advanced manufacturing strategy and the impact that it is and will have on the force. I know your team is working hard on so much more, and we have so many more episodes that we're going to be dropping, so be sure to stay tuned for more episodes that are dropping later this fall. Any final thoughts?
Yeah, there's only two types of soldiers out there. Those that want to be Ordnance soldiers and Ordnance soldiers. Go Ordnance.
Go Ordnance.
Thank you both again. And also, if you're interested in a further breakdown of advanced manufacturing, then be sure to check out the article, Transforming Army Sustainment Through Advanced Manufacturing by Major General Gavin Lawrence and Major General Michael Lawler, that was published in the spring 2025 issue of the Army Sustainment Professional Bulletin. But that is all we have today, folks. As always, Sustainment Leaders start here. See you next time. Thank you for listening to another episode of the LOGSTAT. We hope you enjoyed today's conversation. Please share this episode across your formation and leave us a review. If you have a topic you'd like here discussed, then please reach out to us at armysustainment@army.mil or directly to me on Global at garett.h.pyle. Follow us on Facebook, X, and LinkedIn at Army Sustainment. We'll see you next time. Sustainment Leaders, start here.